Alright, this video is just going to be a few different examples of how to graph an ellipse and or find its details depending on what the type of problem you run into starts you with. So, hopefully you already know the basics of a conic section. If not, you may want to find another video discussing the basics of what the conic section ellipse definition looks like, such as the equation up here at the left. We've got an x squared, a y squared, and again we've got two numbers on the bottom, and we always want to be equal to 1. Remember, we know it's an ellipse because we have fraction plus fraction. X squared plus y squared typically makes us think of a circle, but again our 4 and our 36 tell us we're going different dimensions. So the first thing we want to remember about our definition is the larger of our two numbers, remember, is always what we called a squared, and it always is where we'll get our vertices. So if I'm thinking about the vertices of this equation here, well, a squared is 36, which means that a will be equal to 6. And I know that it's underneath the y squared, which means I'm traveling in the y direction. I also know that from x and y squared not being shifted around, that means that we're centered at 0, 0. So I can go 6 units in the y direction, or basically 6 units up and down from 0, 0. So I know that my foci will be 1, 2, 3, 4, 5, 6 units up, and again the same thing, 6 units down from the origin. Now, in order to get any other coordinates, we need to know a little bit more about the rest of our ellipse. Again, our other number we typically define as our b value. It's sort of our minor vertices. So b squared equals 4, which means that our b value is going to be 2. So we're going to travel 2 units to the right and 2 units to the left. We also know that in order to get the foci, we need to find our c value. Well, for an ellipse, remember that a squared minus b squared equals c squared. So c squared will equal 32. And the square root of 32, or plus or minus that number, well, the square root of 32 is equal to 5.657 approximately. So again, the square root of 32, or approximately plus or minus 5.657, which means that again we can travel up about 5.6. Again, sometimes it gets a little bit tricky to draw those points in there, and down about 5.6. Tell you what, I'm going to cheat a little bit. I'm going to construct ourselves a circle real quick here. Let's put our focus right about there, and again 5.6 down at the bottom, down here. Now again, the narrower your ellipse, the harder that might get to be, because again your foci are so close to your vertices, but do try to make sure that they show up on your graphs. After that, it's just a matter of drawing in your actual ellipse, which I'm going to cheat a little bit and drag one in here, but you will notice that again from vertex to vertex and minor vertice to minor vertice, 6 units up and down, 2 units left and right, we have a decent looking ellipse right around the center there. Again, our foci would have been 0 plus or minus the square root of 32, or 5.657. And the last thing to find would be our eccentricity. Now, because it's a fairly long ellipse, we expect an eccentricity fairly close to 1, which, remember, we just take our c value, so the square root of 32, and we divide by our a value, which would be the square root of 36, or basically 5.657 divided by 6, and we get 0.943. Again, a number reasonably close to 1. Let's take a look at another example very quickly. What if, got a little ahead of ourselves there, what if they gave us the vertices and the foci, and they ask us to go back and find the equation? Well, let's think about the fact that the vertices are going to be our a values, so immediately that tells me that a equals 4. We know that the foci define our c value, So immediately being plus or minus 2, notice in the same direction as the vertices, we know that C is 2. Think about your equations, think about your shortcuts, see if you can't come up with the B value, and define an equation as well as a graph down below. I'll pause the video now and fill in the answers, and let's see what we can do. Alright, let's take a look here. Again, we knew what A was, we knew what C was. Taking advantage of C divided by A, we can find our eccentricity of 0.5. Now you'll notice that our graph came out very round, but again, anywhere from 0 to 0.5 or so is going to look very round. It doesn't take much to look a lot like a circle. But it's definitely an ellipse. Our B value came out to 3.464 using our A squared minus B squared equals C squared equation. Again, basically the square root of 12, or 3.464. Again, everything's plotted on our graph. And to write our equation, remember we were centered again at the origin. So again, x squared and y squared, no subtraction needed. And 12 and 16, a squared. Again, a was 4, so a squared is 16 in the y direction. B squared was 12. So again, that's going in the x direction. So it goes beneath the x squared. X squared plus y squared equals 1, making our equation. Let's try this one out, only let's just change it just slightly. Centering everything at the origin sometimes just seems a little too easy. So what if we set our vertices instead were at 8, 1, and 8, or sorry, negative 8, 1. Or even better, how about we call this negative 8, a negative 7? We'll call this one a 9. Let's just move ourselves just a little bit here and there. Think about how that's going to affect your equation, how that'll affect your details. See if you can't find, again, A, B, and C. Find the foci, find the vertices, which were given. But let's see if we can take advantage of that eccentricity to find the rest of the details and do the rest of this thinking. Now, one thing you want to remember, the eccentricity is a ratio. So even though we know that from 9 to negative 7 is a total distance of 16, our A value, as it was before we shifted everything as well, is still 16 divided by 2. Our A value is still going to be 8. The distance from vertex at 9, 1 to negative 7, 1 is still a full 16. Our center will be halfway in between, but again, a distance of 8 for our A value. All right, pause the video now, see if you can work from there, see if you can find more details. All right, so I've got the details down here. Again, the first thing we'd want to figure out is where's our center. Everything's going to be measured from there. So because we were halfway between 9 and negative 7, halfway between negative 7 and 9, well, if we add them up and divide by 2, we find that center to be 1 unit to the right of the origin. And because, again, the y values were both 1s, well, if the vertices are both on the value of y equals 1, so will the center and so will the foci be. So again, we've got everything up at 1 unit as far as our major axis goes. Our major axis would be y equals 1. Our sort of minor axis would have been x equals 1. So we've got our center at 1, 1. We're going to add 8 units and subtract 8 units. Again, that puts us right at our vertices. We're also going to add or subtract 5.292. You'll notice I took 64 minus b squared equaled c squared. So again, using our equation there, we ended up with our 28. Now we might want to know where that c came from. Remember, if the eccentricity is 3/4, that's just a ratio of c to a. And we knew that a wasn't 4, a was 8. So 3/4 was equivalent to c over 8. Well, that means that c needed to be 6. And with a 6 squared for our c squared value, that makes b into the square root of 28, or b squared into 28. All right, with all of those details in place, then we drew out our graph. Again, from center up and down, 5.3 or so. Left and right, 8 units to the vertices, 6 units to the foci. And up here in the equation, it just meant that when we're not centered at 0, 0, we were 1 unit to the right, x minus 1 squared, plus 1 unit up, so y minus 1 squared. We're traveling in the x direction for the major axis, so 64, or 8 squared, goes below the x. In the y direction, where that square root of 28 squared, or basically 28, is b squared. Let's look at one last problem here and see if we can't, using very little information, come up with our details. Take a second, think again about how you can find all the other information. It's very important we find a, b, and c. It's also very important that we find the eccentricity to help us know if it's going to be very round or narrow. Also, having those foci in place just helps give a little bit of extra detail in order to write that equation. Again, pause the video now, fill in your information, and let's see what we can come up with. All right, so from the major axis having a length of 10, remember that 10 technically would be equal to 2a then. That's the entire major axis. So a is half of that, or 5. Again, the foci, or 3 units to the right, 3 units to the left, or a c value of 3 down here on our graph, which means our eccentricity, again, is 3/5, or 0.6. So again, not quite a circle, obviously, not that close to 0, but still fairly round. Our center would be halfway between those two foci. Well, it's very important that we use those to find the middle, which just happens to, again, fall at 0, 0, which means our equation is x squared plus y squared equals 1. Finally, using a and using c, we can define our a squared minus b squared equals c squared equation, figure out that b squared is 16, so b is plus or minus 4. We went 4 units up, 4 units down, and again, drew in that ellipse as far as that goes. Again, don't forget to also label a little bit. We put our 5 out here, maybe put a 4 up there, just to tell us where those details are as far as those lengths go. Last part to fill in is just to finish our equation. Remember that we traveled in the x direction, which means that a squared, or 25, should go beneath x squared. And in the y direction, that's our b squared. B squared was 16 in the y direction. Again, hopefully that helps you, just working through a few different problems, talking about the equation, talking about the details of the major axis, again 2a, or twice the length of that a value, b traveling the other direction, the foci as they relate to c, and how you can take advantage of that eccentricity a little bit as well. Remember to watch out where that center is. If it's not centered at 0, 0, then we've got to add or subtract within the parentheses for x or y, depending on where we want to move them. Good luck. If you have any questions, make sure you talk to your teacher. Otherwise, have fun.